It's a cute little mini PC, and it's nicely built. This episode of Some Gadget Guy is brought to you by viewers like you. All of the amazing people who share videos on social media and the incredible generosity of my patrons at patreon.com/SomeGadgetGuy. More info on those brilliant nerds later in the video. Alright, so this one kind of took me by surprise a little bit, but the folks at Geekom reached out to ask if I would be interested in spending some time with the Asus NUC Pro. It seems the team I work with is going to be doing some collaborating with Asus. Geekom makes some of my favorite mini PCs, and the NUC line is one of my all-time favorite lines of little mini PCs. I'm not 100% sure what the relationship is there, but it's kind of peanut butter jelly time for me. New toys! So yes, the Geekom folks sent this my way for me to take on a test drive, share some thoughts. The mission of a mini PC is really fun. It's a little different than laptop or gaming PC conversations. As a laptop chip ages, the company making that chip starts looking at ways to sell off inventory before a new chip is launched. I'm grossly oversimplifying the supply chain. So when we're not quite a full generation out, we start seeing these great laptop processors in little tiny boxes. The standard bearer for this form factor has been the NUC. Originally a division under Intel, now owned by Asus. The NUC 14 Pro here is, cleverly, a 14th generation Intel chip in the configuration sent to me. The Core Ultra 7 155H with 32 gigs of RAM and a 1 terabyte SSD. And this is the taller case, which the user can also add a SATA SSD, but I'm getting a little ahead of myself. Cracking this thing open, Asus touts a toolless chassis, and that's kind of refreshing in this product category. Usually on these little 4x4 frames here, we have the 4 screws in the feet, and that pops this bottom tray out. Here, we have a flathead screw and then this little rocker switch, which unlocks the bottom, and that opens the whole PC. Once we get inside, it should look really familiar. The RAM and SSD right up top. And I love to see those brand name parts. Crucial RAM, Kingston SSD. The SSD is seated with a little plastic plug, so there's no fiddly screw to cinch that down. I've lost a few in some of these PCs. And under the SSD, we see the Intel wireless chip on the motherboard. With those little antenna clips, I got really good Wi-Fi and Bluetooth performance from this box. And there's room for expansion. There's a smaller NVMe slot, also with a little plastic plug. And in the tray that we pulled out, there's the caddy for a SATA SSD. And it seems to be a trend with Intel mini PCs that we've played with recently, that there is no SD card slot around this frame. I like having that option built in, so with something like this, you'll need an external card reader. Front of the NUC has a 20 gigabit USB-C and a pair of 10 gigabit USB-A, and I love that we're labeling these ports now so that people know what port does what. On the rear, we've got 2 HDMI and a pair of Thunderbolt that can also output video. You should be able to run a quad display setup. 2.5 gigabit Ethernet is becoming more common, so I'm glad to see that also. And then one more 10 gig USB-A and an accessory USB 2 port. Small shell, but super flexible and lots of options to customize. NUC still stands in contrast to something like a Mac Mini. You can't upgrade the processor here, but you can upgrade RAM and storage and add a lot to this system over time. Asus will build it for you, or you can buy this bare bones and select your own components. That's another difference I like after Asus took over the NUC line. The Intel machines were all bare bones, and you had to install everything and pick your parts and your operating system, and Intel prices were often higher than other mini PC competitors that would give you a fully built system with an OS. Asus gives you the choice to build your own or buy a system you can use directly out of the box. And they accessorize it a little better than Intel did, like giving you the VESA mount so you can bolt this to the back of a monitor or a TV. The power supply is a nice smaller unit, and it's still a 120 watt brick. The nice thing about moving a laptop chip to a desktop shell, you can run that thing harder, and there's no expectation that you need to conserve power for battery life, which is where we should chat about really using this thing. It's another aspect that likely contributes to the higher price over other mini PC manufacturers, but we get a proper UEFI that's a lot nicer laid out. Several of the other mini PC options that I've played with, when you go into that BIOS, it looks like an old BIOS. The Asus flavor on this is a lot easier to navigate. Plus, I can go to the Asus site and there's just a wonderful page of support for firmware and drivers and BIOS updates, which we can't always point to on other mini PC brands. So I ran the most recent BIOS update for this, and I did all the Windows updates and rebooted several times and all of the App Store updates, and then also configured the Asus to use the higher performance fan curve. So glad to see that in software where we can tell the box just go full power and keep it as cool as you can. That is a funny feature that we've seen on some of the other mini PCs that I've reviewed, where you might get a big rocker dial that we can rotate for quiet operation or better cooling, but that's kind of simple deliberate. This feels a little more refined. We want to get a feel for what an untethered Core Ultra 7 might do, and this has been one of the best performing flavors of the chip that I've used. And with simple Geekbench and synthetic scores, we're falling a little behind Qualcomm's ARM chips for CPU performance, but the big win for Intel year over year is the improved integrated GPU. It's a huge step up over Intel's 13th gen. It's a good step over Qualcomm's GPU, and even a tiny improvement over the 8000 series AMD GPUs. These numbers are very encouraging. Now, in something like a file compression test, the Core Ultra 7 is roughly 20% more powerful in 7-zip than a 13th gen Core i9. In this config with the fans cranking, it scores about 8% better than my Qualcomm Surface Laptop 7. Those scores flip on a browser bench where my ARM PC can just squeak by the Core Ultra 7, and into a content creation test running my 1-minute 4K video render, the Core Ultra 7 is a huge improvement over the 13th gen Core i9, and it's a small win over the AMD and my Qualcomm render times. In one generation, Intel became a lot more competitive for doing something like home video editing. Cutting up 4K video is entirely doable on this box. And looking at some gaming, I still like to start with Tetris Effect. In only a handful of years, we've gone from struggling to play Tetris on integrated graphics at the lowest quality settings in 720p to now playing Tetris at 1080p with ultra graphics. You see, Tetris isn't the most amazing graphics intense game, but you can't really play Tetris if the frame rate keeps dipping. Intel now delivers a solution that can hang with Tetris at 60 frames per second and rarely dropped below 60 FPS. In my marathon run to 150 lines, I only saw the game dip to 58 frames per second once. That's pretty good. I mean, my favorite games are totally cake to play now at 1080p and at high quality. This box won't struggle at all with platformers and roguelikes. Hades 2 looks gorgeous. The frame rate pins at 60, and it's a great experience. And the happiest improvement for me over 13th gen Intel, proper complete support for Unreal Engine 5. So now we can play games like RoboCop at low, maybe medium graphics, and with some kind of scaling tech employed like FSR. There's a lot you can tweak, but even scaling way back on quality, the game still looks pretty decent, and you can keep frame rates comfortably above 30 frames per second. Last gen Intel Iris graphics did not support everything UEFI needed for this game, and it would just crash when launched. Again, in one generation, now it's decently playable, if not quite console quality, still something I think folks might enjoy. No one would confuse a mini PC with only integrated graphics as a hardcore gaming solution, but like my Qualcomm and AMD PC reviews, it's really easy to find fun games to play on mainstream graphics hardware now. They might not be gaming PCs, but they can play some games. Really maxing out the performance here did require a trip through the UEFI and the Windows power settings, and it does come with a bit of a compromise for noise. I remember when I was holding it up, we had a 120 watt power brick, and the best CPU performance wins we see against my Qualcomm laptop are between 8 and 10% in conditions where that might not be noticeable unless you're running two computers side by side. Like an 8% difference in file compression likely won't be tracked as you're watching the slider on Windows File Explorer. Or a 10% difference in video rendering amounts to about a 3-second difference in rendering time when you're finishing up a 1-minute short or a reel or a TikTok. But the Intel part is drawing a lot more electricity at full load to achieve those scores against my ARM laptop PC. One of the primary differences between going laptop with a battery or mini PC that's just plugged into the mains. Productivity and more CPU-bound tasks, that is a healthy fight between two different architectures, but gaming is definitely an easy win here over ARM and going toe-to-toe with AMD in a way that we haven't seen before. As I mentioned, that fan curve, the curve is really aggressive. I mean, it's actually kind of refreshing. I said go all out, and the box goes all out. But that means the fans scale a lot. Even in a somewhat consistent task, the fans are gonna ramp up, spinning up, and then calming down based on the temperatures. I appreciated how tight that scaling was to system conditions, but I think some folks might find that constant change in tone a little distracting. I think it's worth going through the Asus software and just looking at your fan and cooling and performance settings. You might want the box to just go full power or full fan speed sooner than you'd otherwise need it to, but have it run more consistently. That's the noticeable difference between the NUC and a laptop running that Core Ultra 7. You just can't let a laptop scale up to the same power draw and go full out. In a CPU render and resolve, a laptop with the same Core Ultra 7 was a lot slower. Lastly, I still think it's silly how hard Intel is pushing AI and how important an NPU is to Copilot when there's so little that seems to tap that NPU. Like in the Windows Photo app, you'd think using generative erase would use that fancy new NPU. Nope. No NPU activity found while erasing objects. On my Surface laptop, the Co-Create feature will use the NPU, but that's hot garbage. I don't get why anyone is interested in this. You can doodle, and then the computer will randomly guess what you want based on a prompt, and it gets it wrong. It gets it wrong a lot. Because you're supplying some information first, the NPU is used to try and translate what you draw into another image, but look at this. It's not able to figure out two separate objects with a prompt that includes two separate objects. So on the NUC, in Paint, I can do image generation, but it doesn't use the NPU for that. And it's frustrating because an NPU can be a handy little coprocessor. It helps a lot for things like camera effects and can achieve these little effects more efficiently than ramping up your GPU. We use them a lot on phones and in camera apps because phones are significantly more power constrained. I hope we see more uses on PCs because they can be helpful, but you have to be thinking in the context of low power operation. Any heavy lifting feature, you might be better off taxing a GPU to scale up to a higher tier of performance. Apologies, I'm still on this tangent, but think about how Windows Recall is being described. It screenshots what you do every couple of seconds, and then it scans that data and stores it. That process, if you quickly analyze an image, scrape it for information, tokenize that information for an LLM, and then save that in a database that can be searched by the user, that's kind of the perfect use for a little low-power coprocessor. And this to me becomes one of the primary reasons why you might want a higher performing NPU. You don't need a beefier NPU to blur the background of your video call. We've been doing stuff like that on phones and tablets for years now. But scraping a screenshot, you don't want that system lagging. Recall snapshots every 5 seconds, and you don't want a PC falling behind or chewing on a backlog of screenshots. So we ramp from 10 to 15 tops to 40 tops for a Copilot PC, and that should enable each screen grab to be scraped by that low-power coprocessor with plenty of time for that NPU to spike, complete the task, scale down, and be ready for the next screen grab. I'm not real big on these features presently. It's kind of a bummer because I think eventually a Star Trek computer that keeps a record of the stuff I do on it could be really cool. But we have a lot to sort out on implementation and privacy and security, and I think these companies are getting ahead of themselves. So we end up with a component on our systems that Microsoft is requiring for this stupid Copilot Plus label, but isn't bringing a ton of value yet. I wish there was more developer interest in using these NPUs to offload small tasks and plugins and camera tools and art filters, but it's really lean right now. So I think we're in a good era. We're in a good retail window. You could buy an older chip that doesn't get the magical Copilot Plus branding, but still have a couple of years of heavy use before you'll start wishing you did have a more powerful NPU. And by then, we'll probably see more powerful little coprocessors to jump on. I think you'll be fine for a while. Now, this Asus is going to be a little more expensive, fully configured, than other Windows mini PCs. I mean, with a copy of Windows installed, I don't think it's difficult to find a 155H for less than what Asus charges. That said, the Asus is nicely built, easier to work on, sources name brand components, and is better supported than the other systems I've used and reviewed. When we're talking about a difference of less than $200, I think that's going to be worth it for a lot of folks to check out, especially those who are hoping for longevity and simplicity. You want to pull this out of the box with a system that's ready to go, and you're expecting to run this system for a while. And that goes hand in hand with the philosophy of the mini Windows PC. You can still upgrade it. You'll also hope you'll be able to support it with software for a while. I mean, against a current Mac Mini, that's a competitive price. I mean, if we spec out an M2 to better match this, Apple is gonna cost a couple $100 more. We're expecting a Mac Mini refresh alongside the M4 MacBooks, but right now, Apple's still gonna charge you like $1,400 for something that's gonna lose a lot of fights against the Core Ultra 7. The M2 Pro will have a better GPU than this box, but it's also going to be even more expensive. And if you buy an M2 Pro today, what do you do with that system? That pie's been baked. You can't upgrade it or change it. You can only replace it. But I digress again. We're in a funny spot for consumer PCs. Because of branding and ruthlessly stupid AI hype, you can score some awesome deals on very powerful consumer computers. Not cheap systems, it's not a fire sale bargain, but we're pushing through this generation a little more aggressively because of Microsoft's marketing missteps. I really think these companies focusing on AI are way off the pulse for what's motivating consumers to buy new gear. This box is pretty rad. So I'll have some links down below on where you can shop it, and I don't know, maybe there's a promo code below that you can save a little cash if you're interested in picking one up. Mini PCs are my jam. These things are really fun to tinker with. You can use them for a variety of different projects. I use one as a little home media server that runs my Plex. It's good times, and I love testing and comparing and running these little systems. The folks who get to see the results of my coverage first are my amazing patrons. The folks over on patreon.com/SomeGadgetGuy. This list of people, a huge thank you from the bottom of my heart, as they're literally helping to keep the lights on here in the Gadget Lab, and they're just an incredible crew of really fun geeks to hang out with, so I hope you'll check them out. I hope you'll consider joining the community over at patreon.com/SomeGadgetGuy. Now, you know where you can find me around the rest of the internet, at SomeGadgetGuy, basically everywhere, but these days, I'm spending a bit more time on the Mastodons, a lot less so on the Facebooks and the Instagrams, and definitely not on the Twitters, and I will catch you all on the next review.